Hi students, I hope you're doing well. So today we are back with a new concept from real numbers. The topic is here we have to check whether the decimal expansion will terminate or non-terminate without actual division. I'll just explain you in a in an easier way. For example, if you have a decimal number which is a rational number, a number which is in the form of p by q, let x is equal to p by q be a rational number such that the prime factorization of q is in the form 2 power n into 5 power m, where m and n are positive integers, then x has decimal expansion which it terminates. And thus you have to understand what is a terminating decimal and non-terminating decimal. Regarding this, you might have studied in 9th standard also what exactly a decimal expansion which will terminate, which will not terminate. Okay. So, for example, this we already discussed. 1 by 2, the decimal expansion is 0.5. This we call it as a terminating decimal expansion. What do you mean by terminating decimal expansion? The expansion which will never repeat or which will never continue. See, it is like 0.5, it stops. It will not, we don't want, we are not, it is not possible to divide it or to get the quotient once again. Correct? 0.5 is the final answer for this. We cannot further divide. So similarly, if you take 22 by 7, it is 3.1423 and dot dot. Okay, you keep on getting that expansion. It will never stop. So this is called as terminating decimal expansion. This is called as non-terminating decimal expansion. Okay. And as we know that terminating decimal expansion, okay, non-terminating and repeating decimal expansion are considered as rational numbers. The non-terminating decimal expansion and non-repeating decimal expansion means, again I just explain you, a terminating decimal expansion means a terminated which will stop, means we will not get further. This is non-terminating, which will keeps on continuing. So first one is considered as terminating decimal expansion, second one we consider as non-terminating decimal expansion. So that is the difference. And can we say this as a rational number? No, this cannot be considered as a rational number because no number is getting repeated. See, 1, 4, 2, 3, all different numbers are there. So that, see, there is a research done and they found that it will never stop. Imagine trillion digits will come like this. Trillion, around trillion digits they found out. Maybe now you might be knowing that technology has been advanced. Actually, this pi is invented by everybody knows. It is Aryabhatta. I don't know. If you don't know, you have to know it because he is our Indian, right? So Aryabhatta discovered pi. Okay, the value 22 by 7 only we know, but decimal expansion of the pi was discovered by Archimedes. Archimedes discovered decimal expansion of pi. Okay, he might have discovered only for 8 digits or 6 digits, but now there is a research done and not exactly research, they actually found out the decimal expansion of the pi that almost a trillion digits will come like this. 1, 4, 2, 3 and so on. It will end at almost a trillion digits you can write. They wrote and they got the decimal expansion of trillion digits. Imagine after trillion digits also that expansion not stopped. So it means definitely it is an irrational number. See, after trillion digits also the expansion not stopped. It means obviously that will never stop. You can write trillion once again, what is it? More than that, even if you do division also, it will never stop. So that is the reason that is considered as an irrational. Not only that, even root 2 we have, root 3, root 5, all are what is it? Irrational numbers. Okay, that is definitely it is an irrational number. I just give an example to make you understood. Okay, now why this especially I am teaching to you, because to check whether 0.5, that is a terminating decimal expansion. How we came to know after division, correct? Even 22 by 7 also we came to know by division. But this, especially this is considered as one statement. This is Theorem actually is a proof. Anyway, proof is not required. So statement I explained. When you get the Q is what? Q is the denominator, correct? Means in that case 2. Okay? If you are able to write the denominator in terms of 2 power n into 5 power n, it means the prime factors of the denominator are, if the prime factorization of denominator consists of 2 and 5, then we can say that decimal expansion is a terminating decimal expansion. If you don't have those factors, you have other than those factors. For example, if you get in the prime factorization of the denominator, if you get 7, other prime numbers, 3, 7, if you get other than 2 and 5, okay, then definitely the decimal expansion is non-terminating decimal expansion, and no need to do long division. Now, division method not required. So you can easily, by using this theorem, you can confirm that if you are getting the prime factors other than 2, 5, if you are getting, for example, 3, 7, and so on, because they are not obviously 2 and 5, right? They are different prime numbers. Apart from 2 and 5, whichever the prime factors you get in that decimal expansion or in that prime factorization of Q or the denominator, which it is considered as Q, then we can say that the decimal expansion is non-terminating. If you get 2 and 5 in the prime factorization, we can confirm that the decimal expansion is terminating. That is the difference. So that way, anyway, we are going to discuss in the sums. Before going to that, let me prove one more type of excuse me. Yeah, the proof we did 7 root 5 is irrational. Yeah, the last cases we did 6 plus root 3, and we did root 3, root 2, root 5, and so on, right? Similarly, we have to prove that 7 root 5 is irrational. So, first step, what we have to assume, let us assume to the contrary. First step you have to write, let us assume to the contrary that 7 root 5 is rational, correct? First, what we have to do, first and foremost thing we have to do is, we have to assume to the contrary. Contrary means opposite to the statement. We are assuming that we have to prove that 7 root 5 is rational, but we are assuming that 7 root 5 is rational. Next step, let 7 root 5 is equal to A by B, where B is not equal to 0. As we know that if B is equal to 0, the entire number will become infinity, correct? So, where A and B are co-prime, correct? Where A and B are co-prime numbers, correct? So, we are assuming that, okay, 7 root 5 is equal to A by B, and B is not equal to 0, wherein we are co-prime numbers. What are co-prime numbers? The numbers which have 1 and itself as its factors. Other than 1 and itself, it does not have any other, especially they are prime numbers, remember like that. Anyway, this I am explaining the third time or fourth time. I hope you might have got the the reason why I am assuming as A and B are co-prime numbers. It means it has only 1 and itself as factors. That's all. Now 7 root 5 is equal to A by 5. So can I write root 5 is equal to A by 7B? Correct? So 7 which is in the numerator, when it go to the denominator, it becomes 7 into B. Correct? So what we got, root 5 can be written as A by 7B. And here, where A and B are integers. Remember, here, or we can write here also, here A and B are integers. Correct? So this, before, as we assume these are prime numbers, correct, co-prime numbers, and whether it is a prime number or an even number or an odd number, it should be an integer, right? So A and B are integers. If A and B are integers, we got root 5 as a rational number. Okay, we are getting the same kind of sum we already discussed, the same kind of step we already did in the previous sums. Root 5 can be written as A by 7B. It means you are able to write root 5 in P by Q form. What do you mean by that? If you are able to write any number in P by Q form, that is considered as a rational number. So obviously root 5 is a rational number. We got it. We got root 5 as a rational number. We are able to prove that root 5 as a rational number. But it contradicts the fact that root 5 is irrational. As we know that we already proved in the last class also root 5 as an irrational number. But what we are getting? We are getting root 5 as a rational number. So it contradicts. It means it opposes. The statement, whatever we proved, that proof is actually the correct one, right? Root 5 is rationally proved. But we are getting root 5 as rational. Then obviously root 5 is, or whatever, 7 root 5 is irrational. Correct? Because the fact is, it opposes the fact. As I told, for example, I'll give an example for this. In last class also I did one example I've given. For example, like, fine. I'll just give an easier example to you. Narendra Modi is the Prime Minister of India. Correct? Narendra Modi is the current Prime Minister of India. That is fact. Correct? We are able to prove that Narendra Modi is not a Prime Minister or is not a current Prime Minister of India. Current means present Prime Minister of India. So, what you got from this? Narendra Modi, we know this, everybody knows. All over the world knows that Narendra Modi is the current Prime Minister of India. Correct. But somehow we did some statement here, somebody is saying or some person is saying that Narendra Modi is not a Prime Minister of India. Will you accept it? Of course not, right? Narendra Modi is the Prime Minister, is the current Prime Minister of India. But somebody says that he is not a Prime Minister of India, is not a current Prime Minister of India, nobody will believe, because we know that Narendra Modi is the current Prime Minister. So fact is fact itself. Here also, it may be a, like example, I made you understand. So don't take it in like logical or in English. Don't compare these statements with English, because I'm not an English teacher to you. So to you guys. So what I'm trying to say, here we already proved that root 5 is a rational number. So we are somehow we are able to get that root 5 is rational number, but it is not correct. Correct? That is not the fact. The fact is root 5 is irrational, but we are contradicting the fact. We are opposing the fact. So hence we can prove that 7 root 5, whatever is multiplied with 5 also, root 5 also, it is irrational. As I told in the last class, any rational number multiplied with an irrational number will give you an irrational number. So root 5 multiplied with an irrational number, definitely it will give you an irrational number. Correct? So that's the reason, if root 5 is irrational, even 7 multiplied with that, 7 root 5 is also irrational. Because any rational number multiplied with an irrational number is also an irrational number itself. Okay? Yeah, I'll just explain once again. This is an easier proof. Yeah, I'll just read the statement first. Prove that 7 root 5. Yeah, this is a sum we have to prove that 7 root 5 is irrational. So for that, what we did, first we assumed that on the contrary, as I told you, this is the key point, you should write it. Let us assume to the contrary that 7 root 5 is rational. We are assuming that 7 root 5 as a rational number. But next step is what? Let 7 root 5 is equal to a by b. I am assuming that 7 root 5 is a by b, and remember b should not be equal to 0. If b is equal to 0, this term or this number will become not defined or infinite. So, and also I am assuming that a and b are co-prime numbers. Co-prime numbers means which are not the prime numbers. Okay? Sorry, which are prime numbers. And what are the prime numbers which have only one, and this itself is a factor? Other than that, it will not be having any factor. So root 5 can be written as 7 is multiplying here. Send the 7 to the denominator, which will give you a by 7b. Remember, even though they are prime numbers or co-prime numbers, what we assume a and b, they should be an integer, correct? Even a natural number comes under integers, whole number comes under integers, prime numbers also comes under integers, odd numbers, even numbers, everything should be an integer, then only it is prime number or even number or anything. So a by 7b, a and b are integers, so definitely a root 5 can be written in the form of p by q. If you are able to write root 5 in the form of a p by q, it means you proved that root 5 as a rational number. But we already proved that root 5 as an irrational. So how can you get root 5 as a rational number? So it is contradiction to you. It means we are doing it against the fact. So it contradicts the fact that root 5 is irrational. So hence we can prove that root 5 is, we contradict the fact that root 5 is irrational, and 7 root 5 is irrational. Correct? So root 5 cannot be rational, it should be an irrational number. And remember, as we told you in the other classes, any number, any rational number multiplied with an irrational number, or added with an irrational number, or subtracted with an irrational number, or multiplied with an irrational number, that number is also an irrational number itself. Remember, okay? Fine. So as now we are going to discuss sums based on this, theorem statement, or based on the theorem. So what exactly is theorem states I explained you. Yeah. Let me take an example. 3 by 8. Okay. When you look at this denominator, okay, denominator what we have 8. So 8 can be written as 3 by 2 into 2, correct? You can write 8 as 3 by 2 into 2. So it can also be written as 3 by 2 cube. So remember, 5 is not there. What exactly they told in the denominator? If denominator is what here? 8. So q is 8 here, right? P by q, p is the numerator, 3, and q is 8. We will consider only denominator. We don't want to do anything with numerator here. So we have taken 8. So 8 can be written as 2 into 2 into 2, which is 2 cube. Correct? So this consists of 2. Means you can write it as 2 power n, 2 power 3, right? So but 5 is not there. Can I write 5 power 0? Isn't it? You can write, or what I can do to make you easier, I will just multiply with 5 cube and divide with 5 cube. Why? Because if you write in terms of 2 into 3, see, we are multiplying and dividing, so that is not a mistake. If you just multiply and leave, that is wrong. If you divide and leave, that is wrong. We are multiplying with 5 cube and we are dividing with 5 cube. So what do you get? 3 into, okay, 125, correct? Okay, this can also be written as 3 into 125, 5 cube is 125, and this can be written as 2 by 5 whole cube, correct? 2 by 5 whole cube, because 2 into 5 whole cube. 2 cube into 3 cube, you can also write it as 5 cube, correct? 2 into, 5 whole cube. I'll just give an example or formula for this. A power n into b power n can be written as b power n can be written as ab whole power n, correct? So powers are same, you can multiply the, just you remember it. A power m into b power n can be written as ab whole power n. Similarly, 2 power n into 2 power 3 into 5 power 3 can also be written as 2 into 5 whole power 3. So 125 into 3 can be written as 375, correct? 1 plus 1 is 325, 75, so 375 divided by 10 whole cube, correct? Which is nothing but 375 by 1000, which is nothing but 0.375. Okay? Got it? So I'll explain once again. See, I've taken 3 by 8. So 8 I am doing prime factorization for 8. If you do prime factorization for 8, you will get 3 divided by 2 into 2 into 2. So which can also be written as 3 by 2 cube. So what is missing here? We have 2, but 5 is not there, correct? So what I did, I just multiplied with 5 power 3 and divided with 5 power 3. So when you multiply and divide, why I am doing that? So that even you will get 5 power 8 over 10. Correct? We have converted it. So when you multiply with 5 cube, see any number you can multiply and divide with that number. For example, you have 2 here. If I divide it with 2 and multiply with 2, what is the difference you will get? Again 2 by 2, it will become 1, 2 into 1 is 2. So you are getting original value back. So you can multiply. This is a basic rule I am explaining. For any number, you can multiply and divide with the same number, the original value will not be changed. You cannot just multiply and live, you cannot just divide and live. If you are doing both, then it is correct. So that's the reason 2 cube is there. That is why I multiply with 5 cube and divide it with 5 cube. When I do that, so 5 cube is how much? 125. And here 2 cube into 5 cube, we have a formula a power m into b power m can be written as ab whole power m. So similarly, 2 power 3 into 5 power 3 can be written as 2 into 5 whole cube. Correct? Just m you take it as 3 there. A will be 2 and b will be 5. So which is nothing but 10 cube. 10 cube is nothing but 1000. 125 is 375. So 375 by 1000 is 0.37. In this entire process, can I did I divided? I'm just confirm with you. Not even once I divided. Correct? Otherwise, you have to divide it 3 with 8 and you have to check whether it is terminating or decimal or non-terminating decimal. But in this entire process, I not even what is that divided 3 with 8. I just followed this theorem, so we got the decimal expansion of it 0.3. Means without actual division, okay, I got the 3 by 8 decimal expansion. Okay, so is it a terminated decimal? See, 0.375 is a terminated stop, right? Okay, because it's an actual value of 3 by 8. Correct, 3 by 8 decimal form is 0.375. So this we can see that this decimal is terminating decimal. How can you say terminating? Because why it is terminating decimal? Because your denominator 8 can be written as in the factors 2 and 5, correct? 8 can also be written as 2 and 5. Remember, if you have more than like 2 factors, for example, 8 is 8 can be written as 2 into 2 into 2. Even 2, you can also write this as 2 into 5 power 0, correct? 8 has 2 as the factor, correct? 2 as a 5 factor, and 5 is not there, no problem. You can write any number. If nothing is there, it will be multiplied with 1. So 1 can be written as 5 power 0, correct? Similarly, I wrote it as 5 power 0. So it has 2 power n, 5 power n. It means it is nothing but 2 cube into 5 power 0. Also, you can write. So when you are able to write like that, so this is also considered as a terminating decimal. Yeah, let me take one more example. Okay, 17 by 8. See, the question is without actual division. Without actual division. Okay, check whether given given fractions are terminating or non-terminating. This is the question. Okay. So let me take one example, which is 17 by 8. Okay. Let me take this example. 17 by 8. What you have to check first? You have to check the new denominator. So again, denominator can be written as 17 divided by 2 power 3, or you can write one more step, 2 into 2 into 2. So 17 divided by 2 power 3. See, I did that to make you understand. You no need to write for every sum into 2 power 3. Again, you multiply it 5 power 3. Again, divide it 5 power 3. Reason I did to get 10 in the denominator. Here, no need to do that. Understood? So, especially don't get confused with this sum and that sum. Here, I did 2 power 3. Actually, we have decimal expansion for 8 is 2 power 3 only. I multiplied with 5 power 3 and I divided with 5 power 3 to get the decimal expansion 0.3. When you do that, you will get 10 in the denominator. If you get 10 in the denominator, you can easily write it. Correct? Because 375 by 1000, just you put the 3 after 3 decimal points. Okay? 0.375. Because 3 are there, how many number of zeros are there? That many decimal points. You have to put that we know. So because of that, I did that into 5 power 3 by 5 power 3. Here not required. So basically what we have to check, here 8 can be written as 2 power 3, which is q. This is considered as p and this is considered as q. So 2 power 3 and q is, we are writing q. It means q we are taking the decimal expansion or the prime factor. So 2 power 3. 5 power 0, can you write? Anything power 0 is 1. So 1 can see anything multiplied by 1 is same number itself. So we don't have 5. Can I write it as 5 power 0? Correct? So 5 power 0 you can write it. So we are able to write this 8 in the form of 2 power m n into 5 power n. Hence 8, what is it? 17 by 8 is terminating decimal. Okay, even if you can divide and check, you can get it. Okay, so without division we are doing just by checking the denominator, whether it is in terms of 2 in the form of 2 power n. Remember, if you get 2 power 3, it means you can write into 5 power 0. That is not wrong. Okay, because any number power of 0 is 1. Correct? Any number power 0. So what I did here, I have taken 17 by 8. I have taken the denominator way. 8 can be just 2 power 3. Correct? 2 into 2 into 2. So 2 into 2 into 2 is 2 cube. But do you have 5 there? No problem. If it is not there, just assume it is 5 power 0. Can we write like that? Yes. You can write, like 1 as 5 power 0. Correct? Nothing is in. Okay? 5 power 0 is nothing but 1 is there. So we are able to write this in the form of 2 power n into 5 power n. We are able to write. That is why this terminating decimal. Okay? Let me take an example which is not able to write so that you will understand. This is one sum. And let me take one more example. Okay? So, because here we, because of the q, the prime factors of q consists of 2 and 5. That's why it is terminating. Okay? Otherwise, it is not terminating. 29 divided by 343 will take. See this, you can easily understand the difference between last sum and this sum. Now, here 343 is the q, right? The denominator is 343. So 343 can be written as 7 sevens are 3. 7 sevens are 49. 49 into 7. 7 nines are 63. 7 fours are 28. Plus 6, 34. So it is 7 cube, isn't it? 7 into 7 into 7 will give you 343. So q, see, decimal expansion of the prime factorization of q is in the form of 2 power n into 5 power n here. No, right? Do you have 2 at least? Do you have 5 at least? No. We do not have 5. We do not have. In the prime factorization, we have only 7. Then easily you can say that this is a non-terminating decimal. Okay? We can easily say that it is a non-terminating. I'll just explain you once again. See, whenever you get this kind of sums, they will give clearly without actual division whether this is terminating or non-terminating. They will ask you to check. Who to check? Just take the denominator. Your denominator 343. You just find out prime factors of denominator. We got prime factors as 7 into 7 into 7. Okay, 7 cube. 7 cube, actually 7 is there. See, what is according to the theorem? In the prime factorization of cube, if you have 2 and 5, you are able to write this cube in the form of 2 power n into 5 power n. Then we can say that this is a terminating decimal. But we are not able to write in the form of 2 power n into 5 power n. Definitely it will be a non-terminating decimal. Okay, I hope you understood. And these are important also because they might ask you for 1 mark. Okay, whether the given decimal fraction is terminating or not. Okay, fine. I hope you understood the sums what we did, and we will be discussing more sums regarding this in the next class. Okay, thank you, and please comment, like, share, and subscribe to our channel and support us. Have a great day.